Hello students, in this lecture we discuss the examples in the exercise 5.4. We have already discussed the 5 examples in this exercise. Now we see the continue the 6th example. Now here, find the coordinates of the foot of perpendicular drawn from the point to the line. Okay, here it is a given point A. Okay, here given point it is A minus 2 comma 3. Okay, it is a given point minus 2 comma 3, and the line here 3x minus y minus 1 equal to 0. Then it is a foot of perpendicular. Here we consider it is a B, it is a foot of perpendicular. Okay, now we want to find the coordinates of this foot of perpendicular. Okay, here see carefully, it is a foot of perpendicular B is the point of intersection of the lines AB and the given line 3x minus y minus 1 equal to 0. B is a point of intersection between lines. So we find the point of intersection, and for the point of intersection we know the both equation of both lines. Okay, it is a given. Now we find the equation of line AB. Okay, and we know that to find the equation of line we know the slope of line and line passing through point. Here line AB passing through point minus 2 comma 3, it is a given, but the slope of line is not given, but the condition it line AB is perpendicular to this line. Then the slope of this line, it is ax plus by plus c. Slope of this line, it is 3. Therefore the slope of perpendicular line, it is a minus 1 by 3. Okay, that means the slope of AB is a minus 1 by 3. Now we know the slope and point. Then to find the equation of line AB, then we know the equation of line AB, it is a given. Then solving these two equations we find the point of intersection of line AB and the given line, that is foot of perpendicular drawn from A to this line. Okay, now here let it is B the foot of perpendicular drawn from A minus 2 comma 3 to the line 3x minus y minus 1 equal to 0. Suppose this is equation number 1, 3x minus y minus 1 equal to 0. Therefore slope of 1 is, it is minus 3 by minus 1. We can write directly 3. Slope of this line, it is a 3, and here we know that since AB perpendicular to line 1, therefore slope of line AB is minus 1 by 3. Slope of line 1 is 3, and therefore slope of its perpendicular line, it is minus 1 by 3. Now we know the slope of line AB, it is minus 1 by 3, and line passing through point A, then we know the point and slope of line. Therefore we find the equation of line AB. Therefore equation of line AB is, it is y minus y1 is equal to m into x minus x1. M is a slope of line, it is minus 1 by 3. x1 y1 with a line passing through point, that is minus 2 comma 3. Therefore y minus 3 is equal to minus 1 by 3 into x plus 2. Okay, now multiply by 3, it is 3y minus 9 is equal to minus x minus 2. Here multiply by 3 and multiply by minus 1. Therefore it is x plus 3y, it is minus 7 is equal to 0. It is equation number 2. Okay, now but to find the foot of perpendicular, that means the point of intersection of line 1 and 2. See carefully, it is line 1 and 2 are the linear equations in x and y. Then the point of intersection is a common solution of these two equations. So we find the common solution. Here it is minus y and it is plus 3y. So multiply this equation by 3. So here minus 3y. Minus 3y plus 3y, y get cancelled. We get the x and then we find the y, and then x comma y, it is a point of intersection between these two lines. And point of intersection means in this problem the point of intersection is foot of perpendicular. Okay. Now 3 into equation number 1 plus equation number 2, this gives 3 into equation number 1, that is 9x minus 3y minus 10 is equal to 0. Sorry, it is minus 3 is equal to 0, and then it is x plus 3y minus 7 is equal to 0. Then we adding this, it is a 10x, y get cancelled, minus 10 is equal to 0, and therefore x is equal to 1. X is equal to 1, by any equation we can find the y. Therefore by equation number 1, 3 into 1 minus y minus 1 is equal to 0, and therefore we can write 3 minus 2, it is 3 minus 1, it is a 2, therefore y is equal to 2. And then point of intersection of lines is 1, 2. That is 1, 2 is foot of perpendicular. Drawn from A minus 2, 3 to line 3x minus y minus 1 is equal to 0. It is a 1, 2, it is a foot of perpendicular. Okay. Now we see the next example. Now next example, example number 7. Find the coordinates of the circumcenter of the triangle whose vertices are A minus 2, 3, B 6, minus 1, and C 4, 3. Okay, vertices minus 2, 3, then 6, minus 1 and 4, 3. Okay. Now here we find the circumcenter of the triangle. What is meant by the circumcenter? Circumcenter is the point of concurrence of perpendicular bisector of sides of the triangle. Okay. Here it is a point of intersection. It is a triangle, any triangle. Okay. Then point of intersection of perpendicular bisectors. Okay. Here point of intersection of perpendicular bisectors. of a triangle. Okay, it is called the circumcenter. Okay, so here we find the equation of any two perpendicular bisectors of the sides. Okay, here we can draw these two or these two sides. Okay, any two perpendicular bisectors of sides of the triangle. Okay, here, and the point of intersection of that perpendicular bisector, it is a circumcenter. Okay, here it is, we draw a triangle here, A minus 2 comma 3, B 6 comma minus 1, and C 4 comma 3. We draw any two perpendicular bisectors. Okay, here it is a perpendicular bisector. Okay, suppose it is a D. Okay, and here suppose it is E. Okay, and here C is a it is circumcenter. It is a point of intersection of perpendicular bisectors. Now we find the coordinates of the point C, and point C is a intersection of the line CE and CD. So we know the equation of line CD and CE. Okay, to find the equation of line CD, okay, first we consider CD. Okay, to find the equation of line CD, we know the slope of the line and point on the line. Okay, here on point on line CD, D is a point on line CD, and we know that D is a midpoint of BC. D is a midpoint of BC, therefore we know the coordinates of the D, that is the line passing through point, and CD is a perpendicular to BC. CD is a perpendicular to BC, therefore we know the slope of CD. We know the slope of BC by using the 2-point form, slope of line passing through 2 points. We know the slope of BC. When we know the slope of BC, we find the slope of CD, because CD is a perpendicular to BC. Then we get the slope of CD and the point passing through line CD. Then we find the equation of CD, and CD is a perpendicular bisector. We know the equation of CD, and same concept we find the equation of CE. Okay, and then the point of intersection of CD and CE is a circumcenter. And now we find the equation, it is solving these two equations, we find the point of intersection. Okay, now here see carefully. First, in triangle ABC, here A minus 2 comma 3, B 6 comma minus 1, and C 4 comma 3. Okay, let it is AD, let it is CF, it is CD and CE are the perpendicular bisectors of sides CD, 1 minute here, C and C, the names are the repeat, circumcenter. Okay, circumcenter we denote the C, so we are denote the point C. Here we take any one point, suppose here P, we can take here P. Okay, therefore PD and PE. Okay, PD and PE. P is a circumcenter, that is the point of intersection. Okay, here PD and PE are the perpendicular bisectors of side BC. PD is a perpendicular of BC and PE is a perpendicular of AC respectively. Okay. Therefore, D and E are midpoints of side BC and AC. and AC respectively. Okay, therefore coordinates of D. Coordinates of D. What are the coordinates of D? D is the midpoint of side BC. D is the midpoint of side BC. Therefore B and C, it is x1 plus x2 upon 2. y1 plus y2 upon 2. Therefore coordinates of D, it is 5, 1. 5, it is 3. It is 5, 1. Now E. E is a midpoint of side AC. AC, it is x1 plus x2 upon 2. X, it is y1 plus y2 upon 2, and therefore you can write point E 1, 3. Point D and E. Now we find the equation of PD. PD passing through point D. We know the coordinate of D. Now we know the slope of PD. Okay, here it is slope of BC is, or slope of BC, directly we can write slope of BC. BC, it is B and C. y2 minus y1 upon x2 minus x1, that is 3 minus 1 upon 4 minus 6. See carefully. y2 minus y1 upon x2 minus x1. Then it is 4 and it is minus 2. Therefore slope, it is a minus 2. 4 upon minus 2, it is a slope of minus 2. Then therefore slope of PD. Okay, here since PD perpendicular to BC, therefore slope of PD is 1 by 2. It is a slope of PD. Now we find the equation of line PD. Okay, therefore equation of PD is, equation of PD, P, it is slope of PD is 1 by 2 and point D 5, 1. Therefore y minus 1 is equal to slope into x minus 5. Y minus y1 is equal to m into x minus x1. It is m and it is x1, y1. So we get the calculation 2y minus 2 is equal to x minus 5. Then here we get x minus 2y. Here x minus 2y, and it is minus 2 becomes plus, therefore minus 3 is equal to 0. It is equation number 1. See carefully. It is x, sorry, here 2y, here minus 2y, 2 here plus, therefore minus 5 there. And slope of AB is equal to slope of AB. Sorry, it is, we want to find the slope of AC. Slope of AC, y2 minus y1, 3 minus 3 upon x2 minus x1, and it is a 0. Okay, therefore slope of line AC, it is slope of line AC, y2 minus y1, x2 minus x1, it is 0, and therefore it is AC is a parallel, slope of line AC is parallel to x-axis. And here, since PE perpendicular to AC parallel to x-axis, and PE is a perpendicular to AC, that means PE is a perpendicular to x-axis, that is PE perpendicular to x-axis and passing through PE, E passing through it is 1,3, and therefore equation of PE is, it is perpendicular to x-axis, that means equation is x is equal to 1. It is line passing through point and perpendicular to the x-axis. Okay, passing through point 1,3 and perpendicular to the x-axis, therefore x is equal to 1. It is equation number 2. Okay, x is equal to 1, then by equation number 1 we get 1 minus 2y minus 3 is equal to 0. Therefore it is 1 minus 2, it is minus 2 is equal to 2y, and therefore y is equal to minus 1. And then point of intersection of PD and PE is 1, minus 1, and therefore coordinates of circumcenter are 1, minus 1. Okay, here see carefully this. Here circumcenter, it is a point of intersection of perpendicular bisectors. Okay, here it is a PD and PE are the perpendicular bisector, therefore P is a point of intersection of perpendicular bisector, that means P is a circumcenter. Now we find the equation of PD and equation of PE. To find the equation of PD, we know the slope and passing through point. D is a passing through point PD, therefore D is a midpoint of BC, then we get this. D is a midpoint of BC, then we get the coordinate of D, and PD is a perpendicular to BC, therefore we find the slope of PD, and then we find the equation of PD, then equation of PE, and the point of intersection of these two lines. But it is point of intersection of, it is equation 1 and equation 2. It is 1, minus 1, and point of intersection of perpendicular bisectors of a triangle is the circumcenter of triangle. Therefore the coordinate of circumcenter are 1, minus 1. Okay, see carefully this. Now see the next example. Next example, find the coordinates of the orthocenter of triangle orthocenter of the triangle whose vertices are A 3, minus 2, B 7,6 and C minus 1,2. Okay, here vertices of the triangle are A minus 2, minus 3,2, 7,6 and 1,2. Okay, here. Now here we find the orthocenter. What is meant by the orthocenter? Orthocenter is a point of concurrence of the altitudes of the triangle. Okay, here altitudes. In the last example we see the circumcenter. It is a perpendicular bisectors of the sides. Okay, now here altitudes only perpendicular, not a bisector. Okay, here it is a triangle. It is B 7,6, C minus 1,2, and it is 3, minus 2. Now we find the orthocenter. Orthocenter is a point of intersection of altitudes. Here we can find any two equation of any two altitudes. Okay, and then the intersection of that two altitude, it is a orthocenter. Here see carefully, we draw the altitude through A. Okay, it is a AD, only perpendicular, not perpendicular bisector. Okay, and BE, it is a perpendicular. Suppose it is a orthocenter, we take here CD, we take the H. It is a orthocenter. Okay, see. Now it is a point of intersection. Yeah, orthocenter नाव द्यायची गरज नाही, काही नाही. Here it is a orthocenter. Orthocenter is a point of intersection of altitudes. So we know the equation of altitudes of the triangle. Okay, we find any two equation of altitude out of three altitudes. Here CF is also altitude which is passing through the intersection. Okay, first we find the equation of AD. Now to find the equation of AD, we know a point and slope. Okay, of AD. Okay, line passing through point AD and the slope of AD. Here line passing through point AD, it is a point 3, minus 2. Therefore x1 y1 line passing through point it is known, and AD is a perpendicular to BC. Then by the condition of the perpendicular lines, we find the slope of AD, we find slope of BC, then we find the slope of AD. Okay, here first we find slope of BC, and by perpendicular condition we find the slope of AD, and same concept for it is BE. Okay, now first in triangle ABC. Okay, here A 3, minus 2, B 7,6 and C minus 1,2. Okay, let AD and BE are the altitudes of triangle ABC. That is AD perpendicular to BC and BE perpendicular to AC. Okay, here AD and BE are the altitudes. Therefore the point of intersection of altitudes is orthocenter. Okay, so we know the point of intersection of altitudes. So first find the equation of altitudes. Okay, now therefore slope of BC is equal to slope of BC. Okay, x1 y1 x2 y2 y2 minus y1 upon x2 minus x1, and then it is minus 4 upon minus 8, and then it is 1/2 minus 4 upon minus 8. It is a slope of BC, and we know that AD perpendicular to BC. Here since AD perpendicular to BC, therefore slope of AD is minus 2. it is a slope of BC, therefore slope of AD, it is a -2. Then equation of AD. AD passing through point A and having slope -2. Y minus y plus 2 is equal to -2 into x minus 3. Okay, see carefully. x1, y1. Y minus y1. y1 it is a -1, therefore it is plus -2 into this. And then y plus 2 is equal to -2x and plus 6. Then the equation of AD, it is 2x plus y minus 4 is equal to 0. It is equation number 1. Okay, equation of AD, it is 2x plus y minus 4 equal to 0. It is equation of AD. Now to find the equation of BE, okay, here, and slope of AC is AC, x2 minus x1, it is 2 minus -2 upon -1 minus 3. Again it is plus 4 upon -4, it is -1. Since BE perpendicular to AC, therefore slope of BE is 1. Slope of AC, it is a -1, therefore slope of BE, it is a 1. Therefore equation of BE is y minus y1. Equation of BE, if BE having slope 1 and passing through point B, y minus y1 is equal to 1 into x minus x1, 7, 6, and then y minus 6 is equal to x minus 7. Take this side, therefore x minus y, 6 become plus, therefore it is -1 is equal to 0. It is equation number 2. Okay, now by solving equation number 1 and 2, here in equation number 1 there is a plus y and it is a minus y, therefore we get equation number 1 plus equation number 2, this gives, okay, x and it is plus 2x, it is 3x, minus y and plus y get cancelled, -1 and it is -4, okay, -1 minus 4, it is -5 is equal to 0. Okay, therefore x is equal to 5/3. X is equal to 5/3. Then by any equation, by equation number 2, we get 5/3 minus y minus 1 is equal to 0. Therefore y becomes this side. Okay, 5/2 minus 1, it is 3/2. Therefore y is equal to 3/2. And then point of intersection of BE and AD is 5/3, 3/2. Point of intersection of AD and BE is x, y, that is 5/3, 3/2, and therefore coordinates of orthocenter it is 5/3, 3/2. Coordinates of orthocenter are 5/3, 3/2. Okay, see carefully. Orthocenter means point of intersection of altitudes. Okay, so find the equation of any two altitudes of triangle and then their point of intersection. Point of intersection means the common point in both lines, that is solve the equations of altitudes. Okay,